So before we do the graphing of this study guide, let's do a quick recap of exponential and logarithmic comparisons and parent equations. So exponent and then logarithmic. And logs are simply the inverse of exponents, the inverse function. So the parent function here is, in this case, our domain is all of going this way. Well, let's come back to domain and range. Let's find the asymptote first. And the asymptote is, again, where is this impossible? And where this is impossible is where y cannot equal 0 under any circumstances. There's no exponent function. There's no value of an exponent that's going to get you 0. You can get fractions, you can get positives, you can get negatives, but you cannot get 0. So your parent function, your asymptote is y equals 0. And then your intercept, you ask yourself, where can, if x is 0, y, so that would be b to the 0. Of course, that equals 1. Therefore, your intercept is going to be 0, 1 right here. And your graph is essentially, your parent graph is, again, infinitely closer to x. So I'm just going to sweep infinitely closer to 0. I'm going to sweep very close this way. It's going to go upwards towards the right. And that would be your essential parent function of y equals b to the x. Therefore, your domain would be from infinite x to the left to infinite positive to the right. Your range is going to start at 0 and go infinitely positive. Not start at 0, but that's your boundary line. Y must be greater than 0, not greater than or equal to. And then your transformations in this particular situation is, if the a value right before the parent function is negative, it is going to flip over the x-axis. So if that's negative, it reflects over the x-axis. And then here, if there is a negative exponent there, that's going to flip it over the y-axis. Shifting, the h is left to right, and remember it's opposite. So for example, if you have a -5 there, you would move 5 to the right, and the k is up or down, and that is as it appears. So if it is +5, let's say, that would be 5 up. So that's just a recap of the parent function for exponents. Logarithms is the inverse. So in a logarithm, your asymptote is x equals 0. So your where it doesn't work, that should be dotted, excuse me, is going to be x equals 0. And if you were to graph this, it's going to look something Therefore, in this case, when x is 1, y is going to be 0 in this case. Therefore, your intercept is at 1, 0, whereas your intercept here was 0, 1. And your function is going to look something like this. It's going to get infinitely closer to 0. Swing around this way. And that is the parent function of a logarithm. If you look very, very closely, let me add the parent function here for exponent, parent function of logarithm. So parent function of the exponent is like this. Parent function of the logarithm is like this. And if you look really, really carefully, you will notice that they're essentially inverse operations of each other. Let me try to graph this accurately. That's not the most accurate thing in the world. But what that means is one is the inversion or the flip over the other, where y equals x line. And in the logarithm, therefore, our domain is exactly opposite. So our domain, okay, it can't be x. So we're going to start at x and go to positive infinity for x. So obviously this way. And our range is going to go from negative infinity, obviously, to positive infinity, ultimately. So it's exactly inverted from the exponent parent function, which is what you expect because logarithms is the inversion of the exponent. And same rules kind of apply here. If this a is negative, it flips over the x-axis. If right before the function is negative, there was a negative here, it's going to flip over, reflect over the y-axis. Shifting left to right is the h. And again, it's opposite. So if you have a -5, it shifts 5 units to the right. K stays exactly as it is. It's up or down. So if there's a +5 there, it's going to go 5 units up. So those are your transformations of the basic exponent and transformations of the basic logarithm. These are your basic log rules. And let's just kind of go over the very first one, which is the most important. Let's just backtrack. Again, logs are the inverse operation of exponents. So your basic exponent started with this, y equals b to the x. And so saying the log of 1 means what would get me 1 here, and that is 0. So any base to the 0 power is 1. Therefore, the log of any base to 1 is 0. It's just the inverse. That's a really important one, probably the most important. So the log of any base of 1 is 0. And that's because of this right here in the left. The next most important is that if the log b is the same right there, then your results is 1. Then, of course, you have the product rule, which means you add the logarithms, quotient rule, which means you subtract the logarithms, And then they get increasingly more complicated, but those first two are the most important, and they're going to come in the graphing that we're going to do. So just what these generalized things should look like. All right. So these are all examples of parent equations without transformations, except for some basic ones. So in all of these, your asymptote is x equals 0. So we'll pretend that's a dotted line there. And so here, this is the original parent function. It's going to go like this. And notice that it's heading towards, if you will, the quadrant 1, which is the positive quadrant. And so your x is positive and your y is also going to be positive. So that is the positive quadrant. Now, right here, notice that x is negative. And remember, when that is negative, it flips over the y-axis. So it goes like this. So it's flipping over the y-axis. Gets increasingly close to 0 on that side. And so notice we are now in the second quadrant, where x is negative and y is positive. And remember, when it's negative right before the function itself, it flips over the y-axis. This one down here, what do you notice? There's a negative this way, so now we're going to flip over the x-axis. So we're going to take that red, and we're flipping it over the x-axis and going this way now. Kind of goes like that. Gets increasingly close to 0. And notice we're heading towards the quadrant 4, where x is positive and y is negative. And that's because of this transformation becoming negative. It flips over the x-axis from here to here. This one, negative, goes this way. Again, increasingly close to 0 going this way, then pulling away from 0 going this way. It's heading towards the third quadrant, which is going to be negative, negative, which is exactly what you see right here, which means you take the parent function and you flip over the y-axis, which took us to the other side, and over the x. So it's a double reflection, if you will. So again, here was the original. There's the original parent function. So we flipped it over the y, and then we flipped it over the x. And that's what got the double negative right there. So keep those 4 visuals in mind as we do our graphing.